So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? You can all use the questions tab to give me a quick information, guys, if my screen is visible to everyone. And you all can hear me loud and clear as well. Perfect. Thank you for confirmation, Edureka guest, Nupendra. Jaideep, Edureka, Ankit, Sumit. Perfect. Thank you so much for the confirmation, everyone. All right. Perfect. Thank you for the confirmation, everyone. So now let's get started. Perfect. So for those who have joined for the first time here, guys, let me start by introducing myself. So my name is Neeraj Kheri, and I've been working in this IT industry for almost 10 years now. So almost for those who have been on the same journey that we have started today, you all must be knowing me. And for those who have joined for the first time, so I've been working on training with the corporates for almost like 5 years now. We have trained the workforce on multiple cloud technologies, including AWS, Azure, DevOps strategies, and all the development technologies so far, right? And this is a sixth session as a part of our continuation of our journey that we have started almost 5 days back on DevOps, where we had seen the entire overview for DevOps, what DevOps is, its entire strategies and tools. And then we had looked at how we can get started on DevOps. We have looked at the concept of version control system and how we can get started using Git and GitHub. Then we had seen the concept of the continuous integration tool, like we had Jenkins, then we had discussed on the containerization tool available, that is Docker. And today we'll be focusing on, first of all, we'll be resuming on the demo that we had to cover yesterday. That means installation of Docker on the server. And then once we are done with the installation of Docker, then we'll be starting off with the concepts of Kubernetes, right? How we can manage the entire cluster of Docker containers that we had created, that we'll be creating in today's session. All right. And for those who are joining via YouTube, guys, so let me first of all introduce you to the concept of Meetup. So we have our own communities on Meetup by the name of meetup.com/Edureka, where in this entire community here, we conduct multiple webinars, more than 150 plus webinars in a given month, right? So if you join this entire Meetup community here, you can be a part of the entire webinars being conducted, where we conduct webinars on multiple topics ranging from cloud computing on AWS, Azure, multiple development cycles, mainly agile, DevOps, and all the different development technologies out there, right? So we have webinars on different topics going on everyday basis. So in a given month, we conduct more than 150 plus webinars, right? So this will be a really good way in order to make sure we all are updated in the current trends and technologies, what is happening in these fronts, and how to get started. So because we cover, each and every module here we try to cover the concepts of the topic that we have chosen. Plus we also accompany that with a small hands-on on that topic that we will be discussing on these different webinars, right? So let me share this link with everyone, so you all can just join this entire webinar Meetup, guys. And once you join the entire group here, you all will be notified on the current schedule on what are the webinars that will be conducted, so that you can be prepared for that same in advance. All right. All right, so let me share this link with everyone, especially for those who are joining via YouTube. All right. So now let's assume from the same point where we had wrapped up yesterday. So yesterday we were looking at the installation of Docker. Now, once we have for the installation of Docker here, what we get now for getting connected to the EC2 instance that we have seen, we can take help of a small tool called as PuTTY, right? So PuTTY is simply an SSH terminal that we can use. Suppose if we have deployed the entire service containers on top of AWS or any cloud computing services, right? Then we can use PuTTY in order to connect to that particular instance over the SSH network, right? And this is a simple connection that we have already established with the network here. So now just to make sure that we don't strain our eyes, let me zoom in the font here. Let us zoom in on the font. Here you go. So let's clear this out. So now this is a simple instance that we have connected to. Now in order to get started on this particular instance, now that currently we are using the Ubuntu image as a part of the entire instance here, right? Now just to get started here, we can simply, as a first step, first of all, we need to have the root user access for this Ubuntu instance that we are working on, right? So here we can, for getting the root user access here, we can use the command as sudo su in order to get the root user access to this one. So as you can see, now we have been granted the root user access here as root, right? So that now just like we right click on any program on Windows and then we choose run as administrators, right? So that we can have the administrator rights in order to access that particular application. Same way here, we can also use the sudo su in order to get the root user access for the instance that we are working on. All right. So now let's get started. So now as a first step here, we can simply enter the command here as apt get update. So now first of all, let's say we want to update here, we can use apt get update, and then all the services that is available on this particular instance that we are connected, first of all, it will update itself so that there is no mismatch, there is no There's no compatibility issues with any of the services which are live, right? Again, if you want to upgrade it as well, we can also upgrade as well by using apt get upgrade. So this will also upgrade all the existing applications out here, right? So again, for those who have joined for the first time, we are currently installing the Docker on the system here, on the system that we were about to cover, yes, in our last class, right? So let us prepare a small document as well so that we can use it as a reference to see what exactly we are doing. So first of all, in order to install Docker, what we have done is we have simply, first of all, change to root user, change to root user using the syntax as sudo su, right? And then what we have done, we have simply update the services. We have to simply update these services. For updating the services, here we can use a command as apt get update, right? And then as a good practice, we can simply upgrade the services as well. Although this is not mandatory, but again, it's a good practice, you know, if we do that, right? And for doing this, we can simply use apt get upgrade, right? And then we can install Docker here. Now, then we can install Docker. Now, for installation of Docker, we can simply use a command as apt get install, and then we can mention the package of Docker, that is docker.io, right? So now once the entire instance here is upgraded, then we can simply use a command here as apt get install and then install Docker, right? So here we can use apt get install docker.io. So this will simply fetch the Docker package, and then it will start installation of the entire package one by one, as you can see here. So this may take a couple of seconds in order to get started. As you can see, once the entire installation is done, in order to check which version we have installed, we can simply use this command as docker version. We can simply use docker version, and then if the installation is successful, then we can simply see the entire version list being visible here as docker version, and then we have 18.09.7 being visible to us. All right. So that's how we can start with installation of Docker that we had to cover. And again, if you want to see the list of all the images here, so if you want to see the list of all the common commands available in Docker, we can simply use a statement as docker help, and this will showcase the list of all the common commands that we can use in order to start working on Docker, right? So as you can see here, we have the for listing out all the images here. We have Docker images for starting. Suppose if we want to list up all the images here, right? So we can use Docker images. So any image which has been pulled and which has been saved here will be visible as a part of Docker images, right? If we want to see the list of all the running containers here, we can simply use Docker PS, and then we can specify all. So any container, whether running or in stop state, they will be visible as a part of this entire command, right? For example, suppose here, as a simple example, we want to pull any of the existing images here. Suppose because Docker has some predefined, or we can say official images already available into its repository, right? So if we want to pull any of the images here, we can simply search for any image. For example, let's say we are searching for an image for Jenkins that we had discussed earlier, right? If we want to search for an image for Jenkins, here we can simply type in as Docker search Jenkins and hit enter. So in case they ask any images available as a part of Docker repository, here we can see it. All right, here we can see the entire listing here, right? And again, whenever we want to refer to the official image, that means the image issued by Docker Inc. as in company itself, right? Then if the image is official, under the official column, as we can see here, it will be marked as okay. If that image is official, that means this is trustworthy. Again, this will not have any kind of bugs or any kind of road pairs, right? As compared to the other being issued by the community itself, right? So suppose if we want to pull the image here, we can simply use a command as docker pull, and then we can specify the image name, that is Jenkins, right? So now if you want to pull this image here, we can simply use docker pull Jenkins, and then it will simply start pulling the entire image, all that means all the packages that has been available inside this image one by one, as you can see here. Right? And again, we know that we had discussed this part. Suppose if we want to create any container here, then containers are also deployed. Containers are also deployed using images, right? And again, suppose now, as you can see here, now once we have the entire image being pulled here, so again we can simply execute this command as docker run, and then we can specify the image name here. Right? Suppose if we want to run the statement here, suppose if we do not want this to be terminated, we can simply mention it as terminated, and then we can simply mention this as terminal, and then we can mention this as the image name, that is Jenkins. And now this image will be pulled here, and the image will be, and the container for the same image will be created. Now we are simply running this image here, and based on whatever is the content of this image, this will be started. Sumit, okay, I have a query from Sumit. So as Docker has a GUI, Sumit, now in order to work on a GUI element, we do have something as Docker toolbox, right? So we do have something as Docker toolbox. Let me show you that. Here we have something as Docker toolbox that we can use in our, suppose say we want to install or work with any existing images here, right? Then we can use Docker toolbox for doing that, because again, Docker toolbox, what it has is, so basically it is simply entire interface, right? For example, and that's why we have named as Kitematic UI itself, right? So Kitematic is simply one of the images that one of the services offered by Docker itself. Now, as you can see here, we have searched for multiple images available, right? Same way here, we can search for all the available images on top of it. We can simply use them to deploy the containers out of it, right? And this can be a simple graphical user interface dashboard from where we can deploy the containers. We can integrate these containers to the Docker Hub as well as a simple graphical user interface. We can do that, right? So let me share this link with everyone as well as Kitematic UI. Let me share this link. Here you go. So is it clear, Sumit? Please give me a quick confirmation. Sumit Chaudhary from YouTube. And again, for those who have joined for the first time, guys, in case you have any questions, any queries coming up, please feel free to drop in your questions directly in the questions tab, so that once I have seen those questions, I can make sure to answer them one by one. All right. So is it clear now, Sumit? Please give me a quick confirmation. Perfect. Thank you for confirming. All right, so that's how we can get started working on Docker here, guys. Again, and now once the entire image has been pulled here, again, what we can see now, the Jenkins is fully up and running that we have initiated. All right. Now, yesterday we had discussed about a small service that is called as a Docker Swarm, right? So we had discussed what exactly Docker Swarm is. So if we have multiple containers, to take care of, right? Then what we can do, we can simply use a service as Docker Swarm in order to organize and manage those multiple containers at once, right? We have seen that part here. Okay, I have a query coming in from someone. Okay, yeah, let me show you how. Suppose if we have already now, if we had deployed the container here, then again we can simply use the command as docker ps, and then we can specify all, so that we can see the list of containers that is currently up and running, which image it has been used to create this container here, and again how long this container has been up and running, and what is the status, right? So this was created 4 minutes ago, and this has been running up almost by 3 minutes now. All right, is it clear now, everyone, with this run? Perfect. Thank you for the information. So now let's focus on our module for Kubernetes today, right? Let's focus on Kubernetes today. So let's go ahead. Okay, sure. Can you please explain a bit about Docker Swarm? So sure, let's go ahead and do that. So let's go into a Picasso mode. Now, if we have deployed, suppose say if we have small containers, right? Now, obviously, tool we need a platform through which we can organize. We can simply take care of the implementation, and we can manage those multiple containers at once, right? We do need a platform through which we can take care of these deployment of different containers at once here, right? And for doing that only, we can simply use a platform called as a orchestration tool, right? And there are multiple orchestration tools available out here. If we want, we can use Kubernetes. If we want, we can use Docker Swarm as well. We have both the platforms available. We have both the platforms available here. All right. So are we clear on this concept of Docker Swarm? Edureka, guest, please give me a quick information. Perfect. Thank you for the confirmation. All right. So now let's resume further. Let's clear this out. So now once we are done with this part here, we can simply exit it as we no longer need this as of now. So today our main focus would be on discussion on Kubernetes as one of the most popular orchestration tool here available, right? So now let's get started on discussion on Kubernetes here. Now we have been discussing on the continuous development, continuous integration, continuous deployment, and now let's discuss on one of the tools available as a part of continuous deployment, that is continuous deployment as a part of the orchestration tool available, and that is Kubernetes, right? So whenever there's a discussion on Kubernetes versus Docker, it cannot be the real case, right? It cannot be in reality, because again, Docker is never compared to Kubernetes, because Kubernetes itself is used for managing multiple containers created by Docker itself, right? So these both work hand in hand together, but again, and they do not work against each other, or they're not compared with each other, right? Because again, they both work on the same principle in the deployment scenario. All right. Now, first of all, if we take a look at the application on host versus deployment containers, now the old way was the application when it was deployed on the host, there were multiple applications, and we have the libraries and we have the kernel attached to them, right? And now, if we are focusing on the deployment scenario here, then each and every application, what it has, each and every application is also clubbed with its own library. That means each and every application can work independently, autonomously, because they are not dependent anymore on the libraries being as an independent part here, right? So now each and every application has its own libraries in which they are packed with inside the same container scenario, right? So that it becomes independent, and all the requirements that is required for running the application smoothly without any errors is already available inside the inside container itself, right? That's the main advantage of containers that we had discussed earlier as well, correct? So, and this actually eases the process of sharing the codes, sharing the entire environment with multiple testing and operations team, right? Because they can take this, because instead of worrying about the configuration at their own system and compatibility issues, right? They can simply use the container which already has all the packages, that means application and all the libraries attached to it. And then they can deploy the same on the production or the testing servers. They can do that easily, right? And that's why we had, and that's why we had you seen that why exactly we use Docker for the same scenario, right? And in case if we have to see the current scenario, the current state of market in terms of adoption to multiple container strategies, and here we can see the enterprises, they have almost in terms of 41%, again, they are already developing it, right? And again, again, as you can see, for almost development in case of actual experimenting part here, again, they almost 41% are actually experimenting with the implementation of containers, right? Where 8% are again in development, where 1 to 10 are again, almost 10% are in 1 to 10 production, whereas 10 plus production are almost, as you can see here in this given scenario, right? And whereas there are only 8% of companies, those who have no plan of adopting to containers, and rest, as you can see, they all are either experimenting or they are already deployed on Docker containers. They have already started using the Docker containers, as compared to just 8% who have not evolved or who have no plans for getting on board on Dockers, right? Whereas even the same case is for small and medium scale businesses, there is only 16% of people who have not planned for the containers, right? Whereas almost all the other companies are either deploying it or they are in the phase of deploying their entire application on top of containers, right? That's how popular the containers have become, especially in the scenario of 2019, because the concept of the continuous deployment is needed by every company, because just to make sure they stay in the market. Because again, if they are slow in adopting to the changes, if they're slow in adopting to the changes here, then that will be really harmful for them, correct? All right, so now let's resume here. Now, first of all, let's see what are the challenges faced without any container orchestration available, right? So now when we talk about the without container orchestration scenario, an orchestration platform is what we discussed, especially beneficial when we are running microservices in containers. We had discussed on the concept of microservices, right? So instead, now just to have a quick recap here, microservices, suppose if we have one particular e-commerce store, we're having these services for the, suppose for cart, for the payment systems, and for the, suppose for the support, right? And these are all are packaged inside the same container itself, in the same environment, right? And if any of these single component fails, so the entire container, the entire application will fail, correct? Same way, just to make sure that the entire application is having a high fault tolerance, what we can do, we can simply deploy these different services in different containers as an independent entity, right? So that even if one container fails here, still, if any component in one container fails, it will not impact the entire application altogether, right? Suppose even if one component fails here, still the application will be up and running. Why? Because we have divided, now instead of following a simple monolithic architecture, what we had done, we simply deployed this, we had simply divided this into multiple microservices, right? And that is exactly what we discussed, because again, orchestration platform is especially beneficial when we have multiple orchestration, or like we can say microservices running in different containers out here, right? That means if we have more number of microservices, that means more number of independent containers we will be needing as a part of our entire deployment methods here, right? So let's erase this part out. Okay, I have a query from someone. Let's erase this up. All right. Now here, as you can see now in this example, here we have multiple services running inside the container, right? Here we have multiple services running inside the container here. Again, now here, the main impact, the main challenge without the container orchestration can be, now in case it simply increases the human cost. Because again, if we do not have any kind of orchestration service or tool deployed here, obviously, anyways, we have to manage the containers, right? Whether with a tool or with human users. And suppose if you don't have a tool available, then obviously we do require human resources for doing that, right? And again, if we hire like more number of human than the tool itself, then that means we have to pay more amount of money. We have to shell more amount of money in management of those containers done by humans, right? And then obviously we have, if we have more number of human personnel, then obviously the size of the bills from the public cloud providers will be increased, right? And again, obviously it will simply increase the complexity of running something new in the production environment, right? And obviously when we have human personnel handling the entire containers, obviously suppose something needs to be automatically scaled up or scaled down, then that will be really tough. Obviously it will not be impossible, but again the entire process will be slower. It will require more amount of time and effort as compared to any automated process done using the tools, right? And then setting up the services manually will obviously be more time consuming, right? And the manual work on fixing a broken node will be, again, suppose if a node crashes, when we say node, it simply means a component or simply means a machine added to any master that we discussed yesterday. All right, so that's why here we can have multiple container orchestration. That's why the birth of container orchestration tools were done, right? Okay, Edureka, guess so increase in the size of builds from public cloud. Please provide. So obviously, suppose if we don't scale up the resources when required. Suppose, let's say when we no longer require those extra number of containers that we had deployed. Obviously, again, if we don't need that as per the given load here, then obviously we can remove them. We can make them inactive, correct? But again, in case we don't have any automated system for doing that, they will continue to run and they will continue to eat up in the bandwidth that we have for a given cloud services. Because again, as we know, whether we are using AWS or whether we are using Azure, both of them, they actually have the pay as you go model, correct? They all have the pay as you go model. Again, we have to pay for the amount of time those servers are up and running, right? And obviously that will be increased in case we don't have any automated system to take care of these, right? So are we clear, Edureka, guys? Please give me a quick confirmation. Perfect. Thank you for the confirmation. And then the solution for this one is the orchestration engine. That's the main solution for this one is the orchestration solution here. So what we have is now the entire architecture dealing with multiple host containers running in production environments demands a set of management tools, because without these management tools, it will not be feasible. It will not be practically possible in order to do that, especially for a large scale application, right? So for example, suppose here we have the first cluster again, in which we had deployed one application. In second cluster, we have multiple other clusters, right? then we had cluster 3 and we had deployed another application. In cluster N, we had deployed another application and all the services attached to it, right? Then again, what we need, we are simply combining multiple containers which are being launched for a one particular objective. Suppose if we have multiple scenarios here, multiple applications having their own components divided into multiple microservices, then obviously we need a cluster, right? We do need to create a cluster out of it so that we can manage all the nodes. That means all the given containers easily. For example, suppose if we are focusing on application 1 itself, right? And we know application 1 is in cluster 1, then we can take care of the changes, we can take care of the deployment, the updates, everything about the application 1 by focusing only on this cluster, right? And when the entire application is also packaged inside a single cluster, then we can be rest assured that there is no single component. Suppose, because again, if in case there is no cluster out here, obviously single, I suppose we can say a couple of containers may be lost as well, right? They may move to some other clusters, right? Which will not happen if we are combining them inside a single cluster altogether, right? And then again, these are all built on top of a cluster manager, or we can say orchestration engine, right? And that's why we discussed on the base what we have here. We have a host OS as a base itself, right? That can be deployed as a part of VM altogether. And then obviously this all is being deployed on top of a physical architecture, or we can say physical interface. So first of all, are we all clear on the concept of orchestration? Please give me a quick confirmation, everyone. Are we all clear on the concept of orchestration here, guys? Perfect. Thank you for the confirmation, everyone. All right, so now let's zoom further. Now we are given there's a big confusion whether we should go ahead with Docker Swarm or whether we should go ahead with Kubernetes, because again these both are one of the most popular tools available as a part of orchestration, right? Thank you for confirmation. Ashish, Ayan, Sumit, Satyanarayan. Sure, Satyanarayan. So basically, suppose if we have to revisit the concept of orchestration here, and basically if we have multiple containers, right? Suppose if we have multiple applications, suppose in this cluster 1, we are deploying one application which is built on, suppose on WordPress, right? Suppose on cluster 3, we are deploying an application into multiple components that application is built on, suppose let's say Joomla, right? And then on cluster 1, we have an application that has been deployed on top, suppose on .NET, or suppose again the same same CMS part as Magento. We can deploy an application on top of Magento. We can do that. Right? And that's what suppose here, and that's why when we are dividing the entire service into multiple smaller components as microservices, obviously it's a good practice to simply create an entire cluster of it, and then so that we can manage everything about the application by focusing only on that particular cluster, right? So the different applications, they can all run independently in their own clusters as a part of orchestration tool. All right. So is it clear now? Satyanarayan, please give me a quick confirmation. And that's exactly why we use orchestration tool. Perfect. Thank you for confirming. So now let's erase this up. So basically, in the area of orchestration, here we have two main platforms that are available, right? There is Docker Swarm, and then we have Kubernetes. Although there are some others as well, but again, these are the most popular tool for management of containers, right? Now, if we have to compare Swarm with Kubernetes side by side, then Swarm offers no auto scaling. Swarm offers a good community. It offers an easy to start a cluster because again, since this is from Docker itself, right? Again, these are having a limitation in the Docker API's capabilities, and then they do not have much experience with production or deployment at scale because again, they are useful not for large scale, for medium to large scale application deployments, right? Suppose if we have a low scale, if we have a low scale requirement, right, for a small application, then we can use Docker Swarm. But if we have a production scale environment requirement, suppose if you want to make an application dynamic and plus it is large scale, then we have to use Kubernetes for that because again, Kubernetes offers auto scaling, right? Now, when we talk about auto scaling here, again, it can be scaled up or it can be scaled down exactly as per requirement because scaling is also of two types that we have discussed, right? When we talk about scaling, there are two main types of scaling available, right? Okay, in case we are not aware about scaling here, let me refresh. Let us refresh what exactly scaling is. So scaling is basically of two types here, right? When you talk about auto scaling here, we have two types of scaling available, right? We have horizontal scaling and then we have vertical scaling, right? When we talk about horizontal scaling here, suppose by default they are two different instances, or we can say two different containers being deployed here, right? Now, suppose in terms of server, suppose they have 1 core of CPU, 1 GB of RAM, 1 GB of RAM, and 1 GB of storage, right? Both the containers are having the same configuration. Suppose there is increase in the amount of traffic or there is a need of additional resources, right? Then in horizontal scaling, what will happen? Some other servers, suppose a new additional servers can also be added as a part of horizontal scaling here, right? So a new instance will be added here as a part of. Now it can be the same configuration, correct? So what we are doing here, instead of increasing the capacity of the already existing servers, what we have done, we have simply increased the number of resources, or we can say a number of containers or number of servers that we have here, right? So now what we can do now, instead of 2, now we have 4, and these can be used to handle the increase in traffic or increase in the load here, right? Same way in vertical, what happens? Suppose the same scenario again, we have to deploy. If we have 2 containers or 2 servers here, right? Again with the same configuration here. Suppose again the same 1 core of CPU and 1 GB of RAM and same 1 GB of RAM here, right? 1 GB of RAM here. Now, in vertical scaling, what happens? Suppose if there's increase in the amount of traffic or there's increase in the amount of load, then instead of adding more number of servers, what will happen? It will simply keep on adding. It will simply increase the resource here. That means suppose from 1 core, it can be increased suppose to 4 cores of CPU and 4 GB of RAM, whatever is required, right? Same way, this can also be increased to suppose for 4 cores of CPU or 4 GB of RAM, right? So instead of adding more number of servers, what we have done, we have simply scaled up the resources of a given service or given container itself, right? And that is exactly what we mean by scaling here. And again, when we are deploying things over cloud platforms, then what we can do, we can simply observe, we can simply expect this kind of scaling to be happen at an automated scale, right? And that exactly is the concept of scaling here. Is the concept of scaling clear to everyone? Please give me a quick confirmation, everyone. So is the concept of scaling clear for everyone, guys? Selena, Shreji, Jagdish, Shredeep, Puneet, Kadri, Ravi, Subhash, Viraj, Sumit, Hayan. Satyanarayan, okay, so can I consider each container as one EC2 instance in AWS? We can say that, but again, the concept will remain same. Suppose if we have one application and we need multiple containers, we have divided those into multiple smaller components, and those will be considered as a container. But then what we have done is we have simply divided the application to multiple microservices as multiple containers, right? Just like we can have multiple EC2 instances running, also we get supporting a single application, right? And for management of these different containers out here, that's why we need an orchestration tool. And that's why we are discussing here on Kubernetes. All right. So is it clear now, Satyanarayan? All right, guys. So let's erase this up. And that's why we have seen these are the main advantages of Kubernetes. It can offer auto scaling. It can have a great active community. It can again, obviously, these as compared to Docker Swarm, it's difficult to start a cluster because again, if you talk about any novice or any beginner who is working for the first time on this entire technology, then for that person, this will be a bit tougher. This will be a bit tougher, right? And this can overcome constraints of Docker and Docker APIs, whatever is being observed in Docker Swarm. And again, this can be deployed at scale more often among multiple organizations. We can do that as compared to Kubernetes, right? And that's why Kubernetes is basically mainly useful for deployment of multiple Docker containers, where it can all be managed inside using the Kubernetes as a main orchestration tool available, right? And containers, they all need to be managed and connected to the outside world for scheduling, for load balancing, for distribution. And again, this is where the container orchestration tools like Kubernetes comes into play, right? Because again, if you want to scale it up using the auto scaling group here, especially when we're deploying this over cloud services, then we need to have a special Kubernetes tool being deployed here. All right. Okay, Ashish, so can we create container for containers for horizontal scaling? We don't create containers for containers, Ashish, but again, if we have multiple containers, then we can use the orchestration tool like we have Kubernetes for the auto scaling part. We can do that. All right. That's why here we use multiple. Here we can use Kubernetes to create the multiple clusters of the containers that we can manage easily using its dashboard. Is it clear now, Ashish? And for the entire Kubernetes here, and again, here we can create the entire Kubernetes here, right? So Kubernetes simply handles the work of scheduling multiple containers onto compute or cluster, right? And can simply manage the entire workloads to ensure that they run as the user intended, right? So here it can be used for management, for scaling up and down the resources, and for deployment of the entire resources using the Kubernetes as a part of the most popular orchestration tool. Okay, Selena, so can we say Kubernetes is a management of containers? Sorry, joined late in the session. No problem, Selena. So yes, Kubernetes is basically used for management of the entire containers that we deploy on top of Docker, right? So if we have multiple, then that's exactly what we discussed just now, right? So suppose if we have multiple applications deployed here, right? And again, in order to manage the entire cluster of containers, that's how we use Kubernetes for. Is it clear now? Please give me a quick confirmation. Perfect. Thank you for confirming. And these are the main features of Kubernetes. First of all, it offers the automated scheduling because Kubernetes can provide advanced scheduler. Suppose if we want to launch the entire cluster at one specific time here, and we want to stop the entire cluster as well, again at a specific time, then we can do that easily using Kubernetes, right? If you want to have self-healing capabilities, that means if you want to replace, suppose let's say we have the entire list of all the containers, right? Suppose in a given cluster, here we have 50 containers, right? Here we have 50 containers up and running, right? Now, here we can simply specify, suppose in case any particular given node, or we can say cluster is not working properly, then then again, it can be simply replaced by another container as a part of self-healing. Suppose if we want to restart the same container here, suppose this has been receiving some kind of errors, and this has stopped responding, then the entire container can be stopped and can be restarted in order to make sure that it is up and running without any kind of errors. Again, we can do that, right? So the replacement, the restarting of any given container as a part of the entire cluster, they can also be done easily using Kubernetes, right? And then we have automated rollouts and rollback. Suppose we want to update, we want to update the configurations here, right? Or we want to roll back for the desired state. Suppose we have, suppose in the entire 50 states here, right? In case in the entire 50 containers being deployed as a part of the entire cluster. Suppose there are 3 containers out here, which again needs to be added. Okay, suppose if they need to be rolled back, right? Then we can do that easily as a part of Kubernetes, right? Again, that we have discussed here, we can also perform horizontal scaling and load balancing. Now we have discussed the concept of scaling here. That means we can scale either horizontally or we can scale up using vertical method as well. We can do both, right? And then we have the concept of load balancing. So basically what load balancing is, let's understand this in simple layman terms. Suppose if we have, okay, first of all, let's erase this part out. Now, in terms of load balance, suppose here we have a load balancer, right? Here we have a load balancer in place here. Now, if we see a huge amount of traffic coming in, suppose what we can do, suppose here we have 2 containers, or suppose here we have 2 containers or 2 particular instances here, right? So if we are working on, if we see a huge amount of traffic coming in, right? So then what we can do, we can simply divide the traffic, suppose equally among the other instances. We can do that so that instead of container, we can simply divide the traffic between these 2 instances here, right? Suppose same way, suppose this one is of a high capacity. Suppose if this one is having 4 GB of RAM, suppose 4 core of CPU, while this one is having 1 core of CPU, right? So what we can do, we can automatically send 70% of traffic coming into our website or to come into application on this instance here, and we can send 30% of traffic coming on this instance automatically, right? Depending upon our requirement. Or we can also set up multiple rules, multiple logics as well. Suppose here we have a website as example.com, right? Now, suppose if the user types in, suppose page A, right? Then the traffic should be going to one server here, to this server. And suppose that if the user types in as page B in the domain URL, right? Then this traffic should be going on to this server. That can also be automated. This can also be set up using the concept of load balancers as a part of load balancers, right? And again, this can also be doable. This can also be doable as a part of Kubernetes, right? So the scaling part and the load balancing can also be taken care of by using Kubernetes, right? And I hope you all are clear on the concept of load balancing as well, as this is something that we discussed for the first time. Is that clear for everyone? Please give me a quick confirmation, guys. Perfect. Thank you for confirming, Selena. Okay, I have a query from Edureka guest. So does Kubernetes has, okay, first of all, let's erase this up. Now, does Kubernetes has alters applications goes down and auto healing, and how does the serving application will be reduced, will be routed to the new instance containers that we had to set that up? That we can set it up depending upon the requirement and how we have configured it. That's something that we can set it up. All right. So we can choose to be notified as well, and again we can choose to be, we can simply define, okay, how this has to be, how this will be working, and then we can choose it to be notified. We can do that. Is it clear, Shuji? Please give me a quick confirmation. Perfect. Thank you for confirming. And now if we have to understand the entire Kubernetes architecture here, first of all, now Kubernetes works on the master and node system, right? So here we have, first of all, here we have a master, right? And then followed by multiple worker nodes. So now in master, here we have the entire API server. Then we have all the controller managers and all the scheduler available, right? And then again, these are all connected. These are all connected to the multiple worker nodes here, right? So here in worker nodes, we have kubelet and then we have kubeproxy. Here we have kubelet and then we have kubeproxy. The kubelet is connected to the multiple pods here, right? And Docker, again, then same way, if you have multiple worker nodes, the same setup will be used there as well. The same setup will be used there as well. As you can see, as a complete architecture followed by Kubernetes, as a complete architecture followed by Kubernetes here. Okay, I have a query. So what exactly do you mean by pod? So pod is simply a collection of the container itself. Suppose if we have multiple containers, right, then we can define them as a pod. As you can see here, as we can say that this is like a cluster itself, right? Where we have multiple clusters, like we have here, we have multiple collection of all the containers in a single cluster, right? That we have seen earlier, that we have discussed. Cluster 1 contains some other application, cluster 2 contains some other applications, right? Same way here we have pods. Same way here we have pods here. And that is a setup for the entire Kubernetes architecture here. So first of all, in master now, again, in the master node, again, we have the UI user interface as well. Again, first of all, Kubernetes can be accessed by both systems, guys. We can access this via the CLI, or we can access this via the UI dashboard as well. Again, for those who are not comfortable working with CLI, we can those users can simply go ahead and use the UI element as well. Like we have a Kubernetes dashboard as well. So let me showcase you a small glimpse of that dashboard, how it looks like. Now this is something like the entire dashboard of how the Kubernetes looks like here. Here we can have the multiple clusters available, right? So here we can discuss, here we can see the entire report in terms of the CPU usage. What exactly is the CPU usage available? Then we can define the Then we can define the memory usage, like how big the memory is being used here. Then we can define all the pods. That means the collection of all the containers, how long it has been up and running, what is the status of that particular container here, how, like, what is the age, that means how long they have been working, what is the CPU and memory usage by these different production, or we can say these different pods available here, right? And then we can define the multiple workloads, we can define the cluster, we can define the roles, persistent volumes, nodes, and namespaces. And that's why it becomes easier for any managers to manage and deploy multiple containers out here as a part of Kubernetes. All right. So that's a UI dashboard that we can work on as a part of Kubernetes, right? Again, these all are connected. These all connected to the API, to the Kubernetes master. Suppose when we have a master and nodes, again we can have master, and then we can connect the same master to multiple worker nodes, as in worker system altogether, right? And then where we have a simple thing as an image registry, where we are working on multiple nodes 1, node 2, 3, 4, 5 as per the requirement, right? And these are all connected to the master as a part of API and controller manager and scheduler for it as a part of master node. And as we know, the scheduler here, so scheduler here is basically responsible for deployment of pods and services onto the nodes here. Suppose if we don't want to deploy this as of now, we want to schedule this for a later period of time, or we want it to be deployed at a specific time, then we can use scheduler for it, right? And basically, and then we have controller manager. It simply allows us to run different controllers inside the same master node here. That is the main job of controller manager out here. And same way, if you to define the entire concept, entire structure for Kubernetes worker, then same concept remains in Kubernetes worker as well. But just like unlike the controller manager and unlike as we've seen in master, right, we have the controller manager and then we have the scheduler, right? So here we don't have the that scheduler and controller manager. Here we basically have Kubernetes and kubeproxy available, right? So here the worker nodes contain all the necessary services to manage the networking between the containers. It makes sure that we are communicating that part well and right. And then we can assign the same resource to the containers that has been scheduled, right? So here the main job of this worker node is to simply handle the entire clusters that has been created as a part of the deployment using the Kubernetes, right? So master can control how the entire clusters will be created when it will be deployed on which particular system out here, right? And then the actual deployment will actually take place on the worker nodes, altogether. All right. So the main job of Kubernetes is to get the configuration of a pod from the API server, and just to make sure that that all the containers described are up and running. That's the main job of Kubernetes, right? To make sure that all the containers are up and running. And again, to get all the configuration that needs to be done for a pod, or we can say that we discussed what exactly a pod is simply the cluster of the containers that we need to deploy here. All right. And then we have kubeproxy, and kubeproxy is simply the load ball. No, the kubeproxy simply works like a network proxy itself, right? And whenever we are working on the load balancer that we discussed earlier, it can be used as a part of kubeproxy, right? And then we have kubectl, just like we have systemctl, right? Same way here we have kubectl. So it's simply a command line tool. If we are connecting via the CLI, then we can use the kubectl to communicate with the API, right? And basically just to send and receive the command itself to the master node. That's the main job of kubectl. Just like we have systemctl, right? Same way here we have kubectl as a part of Kubernetes. And just to understand where exactly Kubernetes is used here, we can simply understand a simple problem statement just like we have for Yahoo, right? So Yahoo is simply a service provider headquartered in Sunnyvale, California. In being situated in California here, again, suppose the problem statement is how to launch a several services on various platforms, right? And basically Yahoo, they archive virtualization of hardware with the help of the OpenStack. OpenStack being a platform, right? And then suppose if the main problem statement here is how to create the images for all the required platforms. Suppose if we have one image required for, suppose for Windows, for Linux, for the SUSE platform, then we have for Debian, for CentOS, right? So again, suppose if one image, if we have to create multiple images for all the required platforms, one application code, and deploy those images onto and deploy those images onto these platforms, right? And how to do that easily without worrying about the manual intervention, without worrying about the manual implementation and organizing of these codes here, right? Then for doing that, we can simply use this entire the Yahoo case study, right? So what we did is that we simply use the code registry as a code management system. So whenever there was a change in the code here, again, we have simply fetched that code by using a continuous integration server, like we have seen for Jenkins, right? And then we have simply deployed this on virtual machines here. Then we have servers, and then we have Docker images, right? And now once we have multiple applications that needs to be deployed for different containers, for different environments here, right? We can create a separate cluster for each and every deployment, and then we can deploy those clusters, or we can say pods, to different environments, right? That's the main job of the Kubernetes, to handle all the pods. That means handle all the cluster of containers and deploy them in their respective environment, right? And that can be done easily. Suppose even with the we can say conventional Docker container setup here, if we would have required suppose 10 days to deploy the same on suppose 50 or suppose hundreds or 100 servers, then the same thing can be deployed within few minutes using Kubernetes as a part of easy management of multiple cluster of containers as a part of orchestration tool. All right. And that's how the entire ecosystem is again created, right? Again, here we have the app APIs, and we can connect using the continuous integration tools here. Then we have J4 Artifactory as a container registry tool available, right? And then we can have multiple service monitoring tools also connected to each other. All right. So basically, in simple layman terms here, what's done is, so again, suppose if we have an OpenStack admin, right? Now they were connected to the entire Git repository, where any change in the code here was fetched automatically, was pulled automatically by Jenkins servers, right? And then once the entire build was created, again, then we have then we use JFrog Artifactory as a part of Docker registry tool available, right? And then this can be pulled by Kubernetes master, right? Now, Kubernetes master, again, it simply works on making sure that the entire application, again, they launch multiple launch pods depending upon multiple environments, right? Based on different nodes everywhere, they can also work on different nodes and different environments. And then instead of doing each and everything manually on different environments one by one, right? That will require more amount of resources, more amount of time. Then this is done automatically and in a sequential and efficient manner by using Kubernetes. That's the main job of Kubernetes here. All right. So are we all clear on the complete setup for Kubernetes, guys? Please give me a quick confirmation, everyone. Edureka Kesh, Kadri-san. Perfect. Thank you for the confirmation, guys. So that's what we had to discuss in as a part of the entire Kubernetes, guys. And again, for the actual implementation part, to see how it actually works, how to set up the entire dashboard and getting started. So we can join the entire certification training that we have to offer here. So let me share this link with everyone for the entire DevOps certification part here. Thank you for confirming, Sumit, Nathan, Shiva. So let me share this entire link with everyone, guys, where once we start the entire implementation on different tools as a part of DevOps, then we'll work on each and every module in detail. So let me share this link with everyone. Here you go. So currently we have seen the entire overview for the entire Kubernetes tool here, guys, right? And now if we want to dive deeper on how exactly it works, how the companies are using it, and how to get started on getting the actual practical exposure for it, we can continue the same journey in the entire certification training that we have to offer, right? So any questions or any queries before we wrap up for today's session here, guys? I hope you all enjoyed today's session. So I hope you have been enjoying the entire journey that we have started on DevOps, guys. And in case you have any questions coming up, in case you have wanted to discuss something, please feel free to drop in the questions tab before we wrap up for today's session. Perfect. So in case we don't have any further questions, guys, so thank you so much all for joining the entire session today, and let's continue our discussion on the other DevOps strategy tomorrow at the same time, right? And again, for those who are joining via the meetup, so please do rate us excellent in the feedback form, which we'll be getting after we end the webinar here today in the email and in the browser window. So please do rate us excellent as a part of a small token of appreciation for the hard work and time that we have put in. And for those who are joining from YouTube, please feel free to drop in your like on the video. And let's hope to see you all soon in a subsequent session tomorrow at the same time. All right. Thank you so much, guys. You all have been wonderful in the session, and hope to see you all soon in our session tomorrow at the same time. Thank you so much, everyone. Take care. Bye-bye.